today's lesson, we're going to talk about deductive reasoning. When we talk about deductive reasoning, it's using logic to draw conclusions. There are two laws that we're going to talk about, and the first one is called the law of detachment. When you're using the law of detachment, you're giving a conditional statement, which is an if-then statement, and a separate statement. If the separate statement matches the if part or the hypothesis of the conditional, then we know that the then part or the conclusion can also be concluded for the statement. However, if the statement does not match the hypothesis or the if part of the conditional, then we know that no conclusion can be made using the law of detachment. Let's look at some examples. In the first example, we want to determine what conclusion, if any, can be drawn using the law of detachment. If a student gets an A on the final exam, then the student will pass the course. Felicia got an A on her final exam. So the first thing that I want to do is I want to match my statement to the hypothesis of my conditional statement, or the if part, and it does. A student gets an A on the final exam. Felicia gets an A on the final exam. So therefore, we can conclude that Felicia will pass the course. And we can conclude this using the law of detachment, or LOD. In example 2, my conditional says, if a ray divides an angle into two congruent angles, then the ray is an angle bisector. My statement, ray RS divides angle ARB so that angle ARS is congruent to angle SRB. So we have to determine, does the statement match the conditions of my hypothesis, or my if part? So this is a ray dividing an angle into two congruent angles, and it's telling me ray RS is dividing an angle into two congruent angles. They match each other, so therefore we would know that ray RS bisects angle ARB. Since the statement matches the hypothesis of the conditional, then we know that the conclusion of the conditional also must be true. In the last example, it says if two angles are adjacent, then they share a common vertex. Then it's telling me that angle 1 and angle 2 share a common vertex. The statement does match part of my conditional, however, it matches the conclusion, not the hypothesis. So therefore, I cannot draw a conclusion using the law of detachment, since my statement does not match the hypothesis of my conditional. The second law of deductive reasoning that we're going to discuss is the law of syllogism. When we have the law of syllogism, we have two conditional statements. So for instance, it could be if P then Q, and your second statement would be if Q then R. And if both of those are true, then we know that if P then R must also be true. A trick to help you use law of syllogism is you're looking for the if of one statement to match the then of the other statement. A tip that can help you is if you cross out the matching parts, one is a conclusion and one is a hypothesis, then what is left will be your conclusion, which is going to be another if-then statement. Let's look at the examples. In example 3, it wants me to use the law of syllogism to draw a conclusion if possible. My two statements are, if a figure is a square, then the figure is a rectangle. My second statement, if a figure is a rectangle, then the figure has four sides. I'm going to underline the matching parts, and that would be the fact that the figure is a rectangle. Notice that it is the conclusion of the first statement, the hypothesis of the second statement. So if I read what is remaining, then I can draw a conclusion based on the law of syllogism. So my conclusion here is if a figure is a square, then the figure has 4 sides. So if we underline what is matching, and one is a conclusion, one is a hypothesis, we can mark those out, and what is remaining will be your conclusion based on the law of syllogism. Let's look at example 4. The first statement, if you do gymnastics, then you are flexible. The second statement, if you do ballet, then you are flexible. So if we underline what matches, it is you are flexible. You will notice that that is part of the conclusion of the first statement, and it's also part of the conclusion of the second statement. Since one is not a hypothesis and one is not a conclusion, we cannot draw a conclusion based on the law of syllogism. So no conclusion can be drawn using LOS, or the law of syllogism, since my conclusion does not match a hypothesis. They are both conclusions. In example 5, it wants me to use both the law of detachment and the law of syllogism to draw a conclusion. We start with 2 conditional statements. So notice, if it's 2 conditional statements that I'm giving, we're going to start by using the law of syllogism. It says, if you live in Accra, then you live in Ghana. If you live in Ghana, then you live in Africa. So my matching parts are you live in Ghana. Notice it is the conclusion of the first statement. It is the hypothesis of the second statement. So therefore, I can conclude if you live in Accra, then you live in Africa. Now, let's use that conclusion from the law of syllogism with the statement that it has given me to determine if I can draw a conclusion using the law of detachment. The last statement says, Alyssa lives in Africa. Notice that that matches, in Accra. Notice that that matches the hypothesis of the statement. So therefore, we know that Alyssa also has to live in Africa. So by using both of those together, we can draw a conclusion overall.